In this tutorial, we will explain what a custom step is, how to develop one, and how to use it in multiple projects. The main idea of a custom step is to add a capability that isn't present in an existing design assistant step. Primarily, we expect people to be adding proprietary algorithms, either to communicate to equipment such as robots or PLCs, or to perform processing algorithms that they have developed in-house. Custom steps are developed in Visual Studio using C#. We provide the custom step wizard that generates a sample project for you, which you then modify to do the work that you need. The sample project is a solution in Visual Studio jargon. In fact, there are two parts. One part is going to run while you are developing your project at runtime, and the other will be deployed to the camera when the project is deployed. The standard steps contain the main code in CustomStep.cs, and the design time portion also includes the user interface code for the configuration panes so that you can set up multiple parameters at once. The runtime version in the camera doesn't need a user interface file. The ultimate output of the custom step is two DLLs. The one with the CF, or Compact Framework extension, will reside on the camera. We also need to integrate the custom steps with the rest of Design Assistant. This is done through two XML files. The step file, or the .das, includes a description of the step, so when it appears in the Add Step dialog, people can know what it's going to do. Also, it includes any information about external DLLs or MIL licensing that's needed by this step. The step library file, the DAL, includes a list of all the available steps and the category to display them under. In order to develop a custom step, you'll need Visual Studio, an Iris camera with Design Assistant 2.0, and since you'll be deriving your step from the base classes that we provide, you need a reasonable understanding of C# and object-oriented programming. A typical step is going to have several sections: the inputs, the outputs, and the step execution section, which is the code that is executed when your step is run. Any drawings that are done are in the annotation section, and if you were requiring a region of interest for image processing, you can use our sample code to see how to configure a region of interest. The simplest custom step looks like the date-time sample we provide. It has one input, one output, and the run method. The inputs of a custom step are the same as possible inputs of any built-in step. Primarily, they can be numbers, images, strings, or true-false values. By default, all the inputs of any step appear in the property grid. When you select an item in the property grid, a simple configuration pane is automatically generated. If you want to group several inputs together and have a user configuration pane that shows them as a group, you'll need to use the form and dialog tools in Visual Studio. Similarly, the outputs that are generated can be individual values or an array of values. And automatically, the outputs of your custom step are available in the same places as the outputs of any built-in step. That is to say, in the link tree, so that you can include them in links and advanced expressions, and in the Quick Evaluate pane, so you can check their values at any time during execution. A custom step is very much dependent on .NET capabilities. One thing to realize is that on the Iris camera itself, we run with the Compact Framework, reduced version of .NET. Most of the services that are not included are not of interest to machine vision. You have to develop your custom step in C#, but if you already have a DLL that has been written in C or C++ that performs some function that you need, you can call from the C# framework into any of your DLLs, assuming that you can also build these DLLs to run on the camera. Access to MIL is provided through a wrapper class that makes all MIL functions and constants available to you. Since one of the primary goals for custom steps is to allow people to develop proprietary interfaces with robots, controllers, and other equipment. The custom step has a platform class, which gives you access to the underlying communication tools, the network, Ethernet IP, Modbus, I/O bits, and the serial port. The calibration object is also available if you will be working on images in real-world coordinates. However, a custom step does have some limitations compared to built-in steps. For example, the display preview, the result table, and the quick access help mechanisms are not available in the current version of custom steps. Similarly, if you need to define an ROI, you need to do it by setting the properties of the position and size numerically. You cannot draw directly in the display. It's not recommended that your custom step try to change values in the digitizer. That should be done through the camera step in most cases. We provide a variety of sample projects that you can copy over and modify for your own use. The date-time package shows the smallest possible custom step. The FTP transfer package is a sample for network communication protocols. The image rotator package shows how to call mill functions to generate a new image, while the OCR package shows how to import and use a mill context file. In terms of documentation, there are some low-level programmer documents that are reference material, as well as an introductory document that defines the procedures for developing a custom step. The licensing requirements of any custom step that uses mill is reflected by a line in the step file, the DAS file. And if that license is not provided with the camera already, you may have to purchase it separately. Since the custom step is fundamentally two DLLs and a text step file, they're relatively easy to copy onto another system and added to the step library file.